Welcome to PaperCam, Wave of the Future. So right now we're going to see if we can get the rules for exponents when they're raised to the 1 or to the 0 or to a negative power, and we're going to do it basically from scratch. Try to get the rules out of nothing, out of just understanding what an exponent is and not looking things up in a book. So let's just look at some powers of 2. So here we have 2 times 2 times 2 times 2 times 2, and we know all an exponent is a way to notate that. It's not a new idea at all. It's just an abbreviation for this. So we say 2 to the 5, right? So what if I want to just get this number? Well, we'll just need to come up with an abbreviation of this form, but it only is trying to notate that we have 2 2's. So two of them. Similarly, right here, we have 3 2's. Okay, and there's our multiplication symbol. I'll just bring it down. It's kind of a lot of room here, but that's okay. So we see 2 to the 5th is the same thing as 2 to the 2 times 2 to the 3. And you can sort of eyeball the fact that, oh, if I multiply exponents with like bases, I will be adding those exponents, because all this is saying is like, hey, I've got a clump of this many things that I'm multiplying together, and then I'm taking a multiplication symbol and putting it between them. And then there's another clump of things. Here's how many there are in that clump. So if we add these, we're going to get this number. Now, in your travels, you might run into these weird looking things, and you might not be sure what this is, because 2 times 2 right here, that makes sense, but 2 times, wait a second, I only have 1 2, what am I supposed to do? And then here, wait, what, there's not even a, what does this mean? What do I even do with this 2? So let's figure that out. So I'm going to make a bigger stretch of things going on here, and let's see what we can come up with. Alright, so let's just say we have these. So what's 2 times 2? Well, it's 2 times 2, right? 2 to the 2 squared is 2 times 2. Let's write them out first. 2 to the 3rd, 2 times 2 times 2, 3 2's. 2 to the 4th, 4 2's. We'll leave these for now. So what is 2 times 2? Well, that's 4. What's 2 times 2 times 2? 2 times 2 is 4, times 2 is 8. 2 times 2 is 4, times 2 is 8, times 2 is 16. Alright, we know all this. Now we're going to use it to figure these out. So how did I get from here to here? If you notice, these are the same, and when I went up 1, I just multiplied by 1 more 3, an additional 3, right? So to get from this to this, I multiplied this times 2. So let's just kind of make up this little notation here. I multiplied times 2 to get there. And the same thing happens here, because we have 3 2's, there they are, and then, I multiplied by 2 yet again to get there. Multiply by 2. What if I want to go back this way? Well, in order to undo multiplying a single 2, I'll just divide by 2. Right? Same thing here. Divide by 2. Okay. Now let's keep going. So, what's 4 divide by 2? Well, that's 2. So now I'll have a 2 here. And then what's 2 divide by 2? It's getting a little cramped here. I'll make a dividing wall of sorts. Okay. So what's 2 divide by 2, well, that's 1. Just for completeness, let's check these. So 2 times 2 is 4. That checks out. 1 times 2 is 2. That checks out. All we're doing is making sure that this notation that we cooked up here is consistent. Okay? And so I'll put up my little 2's here and my 1 here. So whenever you add 1 going in this direction to this number, you're just multiplying by the base one more time. And whenever you subtract 1 from this number, you're dividing one more time. So now we've got to go into, negative space. And we ran out of room here. So what are we going to do? Let's just kind of go down this way. I don't think anyone will get too mad about that. So what happens if I divide 1 by 2? Divide by 2. What's 1 divided by 2? Well, that's 1/2. And that's what we get for 2 to the negative 1, right? So we went down one more time. We're just going down by 1 here. 4, 3, 2, 1, 0, negative 1. And let's go negative 2, negative 3, and see what happens. So when we divide 1/2 by 2 again, think if you have 1/2 of something, right? Don't worry about rules. You got 1/2 of something, and then you cut that in half. What do you get? You get 1/4. And what if you have 1/4 of something, and you cut that in half? Then you have 1/8. So here's our divide by 2's again. Divide by 2. Divide by 2. And there we have it. So you might notice the pattern here. If we see 2 to the negative 1, we have 2 to the 1, but it's just in the denominator. And if we have 2 to the negative 2, we have 2 to the 2, but it's in the denominator. And why is that happening? It's because when we go in this direction from 1, we're multiplying 1 times 2 again, times 2 again. And we go this direction towards the negatives, we're dividing by 2. Divide by 2 to get 1/2, divide by 2 to get 1/4. So we're getting the same numbers, but when you go this way, they're just good old plain whole numbers because we multiplied by 1 to get them. But when we go this way, we're dividing by 2 over and over. So we're getting denominators that are bigger and bigger. Powers of 2 each time. So there you have it. We derived, just from knowing what an exponent is, we figured out how to get an exponent of 1, how to get an exponent of 0, and how to get negative exponents. And you could draw up the rules from this if you wanted to, but I'll leave that to you. Okay.